Good morning, everyone. Thank you so much for joining me this morning. I'm Claire Ligori. I'm a senior software engineer on AWS CodeBuild, and today we're going to talk about continuous integration best practices for software development teams. So I want to introduce you to a little development team, and I want you to think about whether this sounds familiar to you. So you come in the morning, and this is your team chat room. Is the build broken? I can't even compile the app.
Yeah, me too. I guess maybe somebody pushed a bad change.
Sorry, everyone. That was me. I'm still working on fixing it.
Okay, later on that afternoon.
Oh no, man, the last deployment to our test stack failed.
But it looks like the latest code causes a bunch of null pointer exceptions.
Why didn't we catch this in code review?
Is anyone else seeing test failures locally?
Yeah, I think it started happening after I pulled Ian's latest changes.
That's weird. All the tests work. I think I'm Ian in this case. That's weird. All the tests work for me locally before I push the code. So today we're going to talk about continuous integration. We're going to talk about how to avoid some of these problems that we find in our team chat rooms. First, I'm going to start with an introduction to continuous integration. I'm going to talk about some continuous integration tooling on top of AWS. I'll introduce 3 different techniques for continuous integration. I'll define them. I'll show you how to implement them on top of AWS, what your team will say in the team chat room about these techniques, and then how to level them up, how to boost them. And then we'll finish with final thoughts and some questions at the end. So let's start with introduction to continuous integration. Continuous integration means a lot of different things to different people, but for the purposes of this talk, I want to define it this way. First, developers regularly check in code to their shared central repository, source code repository. Next, automated checks run regularly against the shared code base. And finally, developers get feedback from the automated checks about their code. So this is what I'm going to call the continuous integration wheel. And as you're going through software development, you're basically going around and around this wheel with different velocities, right? So sometimes you get blocked, sometimes you don't. Why does continuous integration matter? So I want to break this up into 3 different themes. First is quality. So based on the State of DevOps report from this year, teams that practice continuous integration and Agile and DevOps practices have a 5 times lower change failure rate. They also deliver faster. So 440 times faster time from the time that the developer makes a commit to the time that that change gets deployed. They also deliver more often, 46 times more frequent deployments. So we're going through months in between deployments to hours in between deployments. And finally, continuous integration makes for happy development teams. So as a developer, this makes me happier. 44% more time spent on new features and new code. So we're not spending time unblocking the build, reworking code. We do it right the first time, and then we get to spend time doing what we love to do, which is building. So we're unblocking developers, but we're also growing their skills faster. So with continuous integration, you get more feedback, more often and earlier in the process. And so you get better faster. Let's talk about tooling on top of AWS. In order to illustrate the techniques later, I'm going to use a sample application, my simple calculator service, newly announced here at reInvent. So pretty simple. We're going to have some simple math here. This is something that I wrote in Node.js. It's extremely simple. Please don't judge me on the code. Add, subtract, multiply, divide. And then I have a few unit tests, and we'll come back to this later, for addition and multiplication. So I have pretty poor code coverage. So here are the tools that we're going to use. I'm going to be the developer. Dave and Drake from our team chat room are going to be developers. And we're going to check in code to a combination of CodeCommit and GitHub. I want to show you what it looks like on both of those tools. I'm going to use AWS CodeBuild for the majority of the regular checks that we're going to run against the code. And then finally, I'm going to use a combination of Amazon CloudWatch events and AWS Lambda. I want to take you down to the primitives here, the building blocks for CI. A lot of the glue here you could do in a CI tool, CD tool like CodePipeline, but I want to show you how to basically build your own CI system, and then you can start to replace that with some of these systems later. So AWS CodeBuild is a service that launched last year at reInvent. It's a fully managed build service. What that means is that you don't have to worry about provisioning servers, patching servers, scaling. It's continuously scaling. What that means is that you don't have to worry about how many concurrent builds you want to run, how many builds your team wants to run at the same time. It's going to scale up to the build volume and not queue your builds up. So it's going to be faster to get builds through the system. It's also pay as you go. CodeBuild will charge you for the build minutes that you use. So there's no monthly fee, just however many build minutes you use. And then it's finally extensible. So anything that you can run on your laptop, basically you can run it in CodeBuild. Any command that you would run on the command line on your laptop, you can run in CodeBuild. There's a few different concepts that we're going to see a lot here in this talk for CodeBuild. So the first one is projects. So this is the CodeBuild AWS console with a list of all of my calculator projects that I'm going to touch on in this talk. There's three components that I want to talk about for the build project. One is the source provider. So you can use CodeCommit, GitHub, Bitbucket, or S3 as the source provider. So as I said, I'm going to use a combination of CodeCommit and GitHub. Next is the build specification. So I mentioned that CodeBuild is extensible. The way that you tell CodeBuild what you want it to run, what code to compile, what commands you need to compile that code or run your unit tests, that's going to be in the build specification. And then finally, the build environment. So the build environment is simply a Docker image that has all of your build tools, language tools, testing tools built into it. CodeBuild has a set of curated, vended images that we maintain. So here I'm using the Node.js 432 image, but you can also provide your own custom Docker image. If you have custom tooling or a custom mix of tooling that you want to use in your build, you can simply build that into a Docker image. So the CodeBuild build specification, build spec for short. So as I said, this is how you tell CodeBuild what to run. So at the top, or I guess in the middle, we've got the phases section. This is something that you would check into your source code repository as a file, buildspec.yaml, or you can add it directly in the AWS console when you're playing around with it. So for the phases section, there's a set of different phases that a CodeBuild build is going to go through. Here I'm using the install and build phases. There's also pre-build and post-build as well. And you can specify a list of commands for any of them. So here I'm doing npm install. So I'm installing all of my dependencies for my simple calculator service. And then I'm going to do npm test. So I'm going to run my unit tests and make sure they pass. CodeBuild is going to give me a success or failure for each of these phases, as well as the time that it took. So you can start to break down your build. If it's a super long build, you can say, how long did this part of the build take versus that part of the build? You can also look at what part of the build actually failed. Was it this command versus that command? Finally, at the bottom, you'll see the artifact section. So this is where you specify, what do I want CodeBuild to upload to S3 for me? So here, I'm zipping up everything. CodeBuild's going to zip up everything for me and then put it in S3. You can specify any other set of files that you want. If there's a specific jar file for your Java, or here I'm including all the JavaScript files and my node modules that's going to get uploaded. So finally, we got through the build project and the build spec. And then there's the actual build. So this is the build history that I'm looking at in the CodeBuild console. And when we drill into one of those builds, we can see some of the build details. So here I'm seeing that I ran this build against CodeCommit, my CodeCommit repository. It did succeed. It was a pretty fast build, 40 seconds. You'll also see the phase details. So you see the full list of phases that the CodeBuild build went through, as well as how long they took and whether they succeeded or failed. And finally, if I scroll down more, there's the build logs. So the build logs for CodeBuild are going to be streamed into CloudWatch logs, but they'll also be shown directly here in the CodeBuild console. So I can go in and see that my poor code coverage, those did actually pass. So as I said before, CodeBuild launched last year at reInvent. We've been pretty busy this year, so I want to share a couple of the things that are new this year. We added Bitbucket support, so you can now build from your Bitbucket repositories. You can now directly connect CodeBuild to GitHub pull requests, so that can be part of your pull request workflow. You can get notified about your builds and hook that up to other workflows via CloudWatch events, so we're going to see that later. You can store secrets in Amazon Parameter Store. So Parameter Store will encrypt usernames and passwords with a KMS key, and then CodeBuild will bring that down, decrypt it, and set it as an environment variable. So it's pretty useful for things like testing against databases, things like that. And finally, you can audit your project configuration with AWS Config, making sure that people are using the right KMS keys, the right S3 buckets, things like that. And finally, we have 3 new features this month. This was last Monday. So we're going to see all 3 of these things in this talk. First is that builds are now able to access your VPC resources. So if you have Elasticache, RDS instances, anything like that in your VPC, you can now run builds, integration tests against those. You can cache your libraries, like your node modules or your Maven jars, in Amazon S3 to speed up your build. And finally, we now support build badges. So in your repo, in the README, you can show whether your build is currently succeeding or passing. Succeeding or passing. Succeeding or failing. So let's jump into the 3 techniques that we're going to go through for continuous integration. And for each of these, we'll have a definition, how to implement it on top of the tools that I talked about, what your team will say, and how to level it up. So I talked about the continuous integration wheel. And essentially, as we're developing, we're continuously going through this wheel with some kind of velocity, with some kind of speed around this wheel. So I'm going to talk about the 3 different techniques in terms of transportation. As I was thinking about coming to reInvent, and I'm trying to book the fastest flight, of course, I thought this was a pretty good metaphor for continuous integration. The destination here is production, right? We want to deliver to our customers. We want to get our code out there. And so the 3 techniques really have different velocities around that continuous integration wheel. So we're going to talk about nightly checks, branch checks, and then finally pull request checks. So let's see what a team looks like without any continuous integration. We have our release deadline coming up soon. Are we going to make it?
I don't know. When's the last time we did a full build?
Probably when we did the last release 3 months ago.
Not great. So let's first talk about nightly checks. So definition here, run a full build and unit tests every night to make sure the application still compiles and the tests still pass. Pretty easy. This used to be the standard in the industry, right? This is not super continuous, but it does happen regularly, okay? So let's look at how we would implement this as a starting point for your team. So first, on top of AWS, we're going to use CloudWatch events. In CloudWatch events, you can define a schedule, cron expression or fixed rate every day. That's going to trigger a Lambda function, which is going to start our build. Let's take a look at this. So this is looking at the CloudWatch events console. And the schedule I'm using is every day at 8 a.m. UTC. So every day at 1 a.m. here. It's going to run a build. And that's going to trigger my Lambda function. So the Lambda function simply starts a CodeBuild build with a specific project and a specific build spec that's stored in my CodeCommit repository. So this is an example of a build that's been triggered at 1 a.m. in the morning, and now it's in progress. And that build failed. So let's look at what happened. here we can see that all of the phases succeeded except the build phase. The build phase failed. And now I can scroll down to the logs that were streamed into CloudWatch logs, and I can see that one of my unit tests failed. So it looks like one of the subtraction tests failed. So at this point, all I know is that something failed. And I may not even notice, okay? So one of the things that we need to do is figure out how to speed this up. Problem here is that I pushed in my change, and now my team is blocked. Now they can't compile anything, they can't test anything. The unit test suite is going to fail, right? So we need to figure out how to speed this process up. Currently, the time frame that we're looking at is if I push it at 5 p.m. broken change, I'm going to come in maybe the next morning at 9, maybe 10 for my team, and the build is going to be broken. So someone pulls down the latest changes, they can't run anything. So let's figure out what this is good for. So the two speed boosts that I want to talk about is one, what is nightly checks good for, right? So we're going to get to some better techniques here, but this is actually really good for certain key things that your team does. So we're going to talk about automating code-based maintenance with nightly checks. And the second is email notifications. So notifications are super important here. The problem is, if I push my change at 5 p.m., come in the next morning, did I actually check that the nightly build failed? No. And so I don't know until maybe my team pulls down the latest changes and they start complaining to me in the chat room. So email notifications, we're going to start out with that in order to give a hint to people that they need to go fix their broken stuff, right? So let's talk about code-based maintenance. When was the last time we upgraded our version of Express?
I don't know.
I'm guessing maybe it could be never.
Not good. So internally at Amazon, we recommend that teams upgrade all of their libraries to the latest patch version every week. And the problem is that no one does this. So here's the problem. Here's why developers hate doing this, right? So here I'm showing the two dependencies that I have for my simple calculator service. Numeral formats my numbers. Express is my web server, right? Pretty simple. This is all of the libraries that I'm actually depending on. I am not, as a developer, going to go in every week and upgrade these. No, thank you, right? No, thank you. So we want to automate this process because we want the code base to be up to date, but we also want developers to spend time on new features and new code. So let's look at how we automate this process. Again, we're going to be using CloudWatch Event Schedule. We're going to do it, instead of nightly, we'll do it on a weekly basis. Sounds good. That's going to trigger the Lambda function, which will trigger CodeBuild. That's going to upgrade everything from my NPM registry, pull in all the latest patch versions of my libraries, and then push that into CodeCommit. So I'm going to regenerate, in NPM it's called a shrink wrap file. So I'm going to regenerate that with the latest versions. Python and Ruby each have this, like a gem file lock in Ruby. So we'll push that in, and it's completely now hands-off for developers. So this is the build spec that I'm using to do this. In CodeBuild, you can use several different build specs. So you can have a build spec for each intention or task that you want to do on that code base. So one is the one I showed before, npm install and npm test to run the unit tests. This is what's going to upgrade automatically my libraries. So at a high level, I'm upgrading everything, regenerating the shrink wrap file, and then pushing it into CodeCommit. And if this fails, hopefully I'll get a notification that there's some kind of conflict, the unit tests no longer pass with an upgraded version, and that's the point at which somebody can come in and do manual changes. So it's much more high-value work for the developers on the team. So here is, I'm doing a nightly shrink wrap here to upgrade the dependencies. This is the CloudWatch Events console. and then we'll also trigger the Lambda function from that. So this is an example of the build that did succeed, upgrading my dependencies. And then here is the commit that my shrink wrapper bot pushed into the CodeCommit repository. So every day, if there's something new in the NPM registry for the Express library or anything that it depends on out of those hundreds of libraries, this will get pushed into the repository. So let's talk about email notifications. So as I said before, the problem with nightly checks is that we get blocked. You push it at 5 p.m., come in the next day, and then maybe you'll try again, push another change that maybe passes, maybe fails. But someone has to notice that that happens in order to go and make a fix, right? Let's talk about how to do email notifications. I can't compile anything this morning.
It looks like last night's build failed.
Oh, well, actually, it looks like it's been failing for a full week.
No one noticed. What are you guys doing if you're not building for a week? Anyway, so let's look at email notifications. So from a build, I mentioned before that CodeBuild will notify you via CloudWatch events. So we're going to take advantage of that here and hook that up to email notifications with Amazon Simple Email Service, SES. So CodeBuild's going to emit a CloudWatch event. That's going to have a Lambda function attached to it, which will send out an email to our team email address. So here, this is the CloudWatch Events console. Again, what we're looking at is I specifically have an event pattern that's going to match some of the JSON that CodeBuild is emitting. And I'm only going to get email for failed and timed out builds. So I don't really care about successes. Those are good. That's going to trigger the Lambda function. And then this is a sample email that's going to send out. So this is what the Lambda function puts together for me. It's going to pull down so it's going to know about the build failure status, but it's also going to pull down the logs from CloudWatch logs. So right away in my inbox in the morning, if it's not completely full, I'm going to see that my unit test failed, and I need to go fix that. I got the email that last night's build failed.
Yeah, me too. I guess someone pushed a bad change.
Sorry, everyone. Yeah, that was me. I was still working on fixing it.
Dave. So the process is working as well as it can, right? So at least the feedback loop is fast enough that when we come in the morning, or as soon as that build fails at night, we're going to get the email, and hopefully Dave will go fix it. So what did we learn about nightly checks? So we implemented it. We're going to run a build every night at midnight or 1 a.m. or fixed rate of 1 day in CloudWatch events. But the feedback loop is super long here, right? So 5 p.m. to 9 a.m., 16 hours, potentially 24 if no one's paying attention. And then we start to get into the cycle where someone pushed a broken change, they wait until the nightly build runs, then they push a supposed fix. That doesn't work. Wait until the next day. So we have this nasty cycle where the builds keep failing, and then no one really trusts the nightly build, right? What's the team impact here? The team impact is that broken code can block the team for entire days. So at that point, you go off and have foam sword fights, right? And your team is not working on new code and new features. But we did talk about 2 speed boosts. One really great use of nightly builds or weekly builds is to automate some of that code-based maintenance that developers, of course, don't want to do, and then doing email notifications. So let's look at how we can get a little bit better and go faster around that wheel. So the next one is branch level checks. So definition. Run a full build and unit test every time someone pushes a new change to a branch in the source code repo. Okay? On CodeCommit, this is how it's going to work. Team members push into the CodeCommit repository. CodeCommit also emits CloudWatch events like CodeBuild does. So in this case, we're going to trigger a build off of any push into a branch on CodeCommit. So back to the CloudWatch events rule pattern again. Here, I'm specifically filtering it down to matching some JSON in the CodeCommit event. So this is going to specifically build only on the master branch. So that's the only thing I care about. So as an example, I've added some subtraction tests because I have super bad code coverage. Unfortunately, those did not work. So at this point, unit tests are failing. The build has failed. So quickly, before the team notices, hopefully, I push a fix, and then the build does succeed. So every time, automatically, I push into this repo, a new build occurs. So how do we do this on GitHub? As I said before, this year we released GitHub pull request support for CodeBuild. So when someone pushes into GitHub, a webhook is going to be triggered in CodeBuild, and then CodeBuild is going to report that status back to GitHub. So this is what it looks like on the CodeBuild project. There's a selection that you can make to enable webhooks. And then on the GitHub side, you'll see in your webhook section the URL that targets CodeBuild. And then for this, I'm just doing the push event from GitHub. So every time someone pushes into the repository, we'll do a build. So same scenario here. I have a broken add subtraction test change. And what you'll see is the little red X there that tells my team that the build did fail. And then quickly, before my team notices that it's broken, I get the green check mark because I pushed the fix.
Dude, you broke the build.
I did. I pushed my change hours ago, though.
Either the CI build just finished, or we didn't notice the failure.
So what can we do about this? So we have the same problem here for nightly builds. Here with branch level builds is the problem is someone's got to notice. Someone has to notice the tiny little red X that shows up on the GitHub website or that the build failed for the CodeCommit repository. So we're going to talk about Slack notifications. We're going to talk about build badges. Both of those can raise the awareness that the master branch is broken. And then we'll talk about caching. So one of the problems with branch level builds is you get immediate feedback after you push, but it's not really so immediate. If it's going to take an hour for you to build, then it's going to be an hour before you know that it's broken. So we're going to talk about caching as a way to speed up that cycle and have faster builds. So let's talk about Slack notifications. Here, we want the chat room to notify us immediately as a bit of a faster way, a more relevant way than email notifications to notify us during the day. So CodeBuild's going to notify CloudWatch events, and that is going to have a Lambda function that posts to a Slack channel. So let's take a look at this one. So this looks very similar to the email notifications pattern. So we're only matching on failed and timed out builds. And then here is my Slack channel for reInvent. So you can see here we have two notifications here, one for the CodeCommit change, where I pushed a add subtraction test change, and that failed. And then the GitHub one, where I pushed the same change, broken subtraction tests. Let's talk about build badges. So build badges can help if we're checking out the GitHub repository, or if you have a lot of different repositories where you kind of want a dashboard view of what's the status of all of my code across all of my repositories. In the CodeBuild console here for the project, you can enable this for your project with the build badge checkbox. So this is my CodeCommit repository for the node calculator service. So if I scroll down, now I can see in the README the passing or failing build badge. So here I can take a collection of, this is just marked down, so you can take a collection of your build badges from across your projects and create a dashboard for your team to kind of check out throughout the day of whether your builds are passing or failing. So that can help a little bit to raise the awareness of the status of the build. Let's talk about caching. We saw earlier how many dependencies I have. I have hundreds of dependencies for the simplest little service. And that can take a lot of time to go back and forth to the NPM registry to fetch all of those tiny little node modules. And the same thing is true for Java or Ruby. It can just take a really long time to download these every time fresh. So in CodeBuild, the environment is fresh every time, so you don't have the nice caching that you have on your laptop naturally in CodeBuild, because it's a fresh environment every time. So this is my huge list of dependencies. Let's look at how we can implement this on CodeBuild. So CodeBuild is going to normally will install everything from your NPM registry. But instead what we can do is actually update, sort of zip all of those up and put them in S3. This is what CodeBuild is going to do for you with caching. So it's going to zip everything up, compress it, put it in S3. At the beginning of the build, it'll download it from S3. And then any updates you can get from NPM at that point. And hopefully, if the cache keeps up, then you won't have that many changes to make. So this is an example of what I've added to my build spec for caching. It's a simple cache section of the build spec. And here, I'm just going to zip up everything that's in node modules. So CodeBuild's going to do that for me with just these few lines in the build spec. And then there's some configuration to make in the project. So I have an S3 bucket where the cache needs to go. And I can specify the bucket, and then I can also specify a prefix for it. So that's going to go into my account, and that's going to be encrypted with my KMS key. So here, previously, my build is pretty fast. I don't have that many dependencies compared to complex projects. But it did bring my install phase down by 30 seconds. So from 34 to 4 is a huge percentage. So that's really helped me and my team to get past all of this installing dependencies and get to the important stuff, which is the unit tests. Is anyone else seeing test failures locally?
Yeah, and the master branch build just failed too.
That's weird. All the tests worked for me locally before I pushed the code.
Classic excuse.
Always break.
So what did we learn about branch check summaries? What did we learn about branch checks? So to implement, run a build every time new code is pushed to a branch. The feedback loop here is the time that it takes to build the code at a minimum. And it can be extended by not having good notifications to let you know that that did fail. The team impact here is much shorter than nightly checks, right? But the broken code still blocks the team. It's still on the master branch where I am also trying to implement changes and run tests locally. We talked about a couple of speed boosts. So Slack notifications, build badges, and caching can really help to speed up that feedback loop and make sure that your team keeps moving forward. So let's talk about the final technique, pull request checks. Definition. Run a full build and unit tests every time someone creates a pull request to get code reviewed by the team. Let's look at how to implement this on AWS. CodeCommit recently, last week, I think, released pull requests. So you can check that out in the CodeCommit console, and I'll show you how it works here. But at a high level, in order to add builds to your pull request, the team is going to propose a CodeCommit pull request. That will notify CloudWatch events. And then that's going to start a build. And then the reverse way, CodeBuild is going to emit a CloudWatch event, which will comment on the CodeCommit pull request with the result. So let's take a look. So here I've created a feature branch for subtraction. I'm adding my subtraction test change, which we know is broken. And I'm going to create a pull request for that. So this is CodeCommit pull requests. I'm about to create a pull request. It's telling me that it is mergeable into the master branch. So I'll give it a title and a description. I'm trying very hard to increase the code coverage here. And then it'll show me, before I create the pull request, the diff that I'm about to put up for review. So now my pull request is created. But my team doesn't have really great confidence that this is actually a good change, right? So let's help the team get confidence, all the other reviewers. And the pull request is created. And then my CI automation pull request bot, which is my Lambda function, has started a build for me. So I have a link into the CodeBuild console to go and check out that build. But it will also tell me when the build failed and it will give me that snippet of logs. So that's super useful because now I can see immediately that my subtraction test failed. And this is not only really great for me as the proposer, but also great for my team members. So my team members can have confidence in Claire has actually proposed a good change that isn't broken, but they can also focus on what's important. Instead of trying to focus on, do I think this is going to pass unit tests, they can focus on, is this good code? Is this secure code? Does this follow our style guidelines? Is this something that we actually want to add to our code base? So, and then they also have better productivity because they can basically ignore this pull request now, right? So this is broken, forget about it for now, Claire will fix it. So then I add my fixed subtraction test change to the pull request, so I push that into this feature branch. So that's updated. There's now a new change that fixed that test. And my pull request bot started a new build. And then once that build is finished, now it's succeeded, and my team can actually review my changes with confidence. So at this point, the team would come in and see the pull request here, and then go and merge my change, hopefully. Let's look at how we do this on GitHub. A team member is going to propose a GitHub pull request. This, again, is going to use CodeBuild's integration with webhooks. So it's going to start a CodeBuild build, and then CodeBuild's going to report that status back. Again, we have the same GitHub webhook that's targeting CodeBuild. But now what we're seeing is, in addition to the push request, where we're doing branch level checks, we're going to do the pull request events as well. So same scenario here. I create a feature branch for my subtraction tests, and I created a pull request from that. Now when I come in, it's going to kick off a build, and that build did fail. So my team can see right in the pull request that the build failed, forget about it until Claire fixes it. And then I push my fixed subtraction test change to that feature branch, and now the build has succeeded. And so now my team has confidence and can focus on the right things, high-value things in this code review. Let's talk about how to speed this up a little bit. So this is very fast compared to nightly checks and branch level checks, right? The team is rarely blocked because we hopefully find all the blocks and failures in pull requests during code review. But there's a couple of ways that we can get better at this, get faster around that wheel. One of the things that we heard earlier was testing can break in the test stack. So we can actually run integration tests. So we want to find bugs, find problems earlier so they don't block the team in the release process. And then finally, we can do parallel builds. So there's two things we can do here. One is we can add more and more tests, more integration tests, static code analysis, security analysis, and then we can also split up the unit tests. So if you have a unit test suite that takes hours, probably no one ran the whole thing locally, so it's definitely going to fail in pull request. You can run parallel builds, so split that all up. As I said, CodeBuild is continuously scaling, so it's not going to queue those builds. It's going to run them all in parallel. So first, let's take a look at integration tests.
Oh no, the last deployment to our test stack failed.
Looks like the latest code causes a bunch of null pointer exceptions.
Why didn't we catch this in code review? Let's look at integration tests. So for my simple calculator service, I added caching. I want to speed it up, reduce the load on my servers, doing all that complex calculations. So I added an Elasticache cluster inside of my VPC that my service can use. I mentioned earlier, this month we released VPC support for CodeBuild. So now my build can actually reach into my VPC and contact my Elasticache cluster. So one of the problems that we see here is the difference between working locally and working inside of the VPC or inside of your infrastructure. So locally, I have an Elasticache service running on my laptop, and I've run all the integration tests against it, and yet it fails when it's running in CodeBuild. So an example here would be, here's my CodeCommit project for CodeBuild. My build failed, very weird. The build phase failed. And here we can see it could not connect to the Redis cache. So I ran everything locally against local host Redis cache, but it failed in integration tests. So one of the things we can do is start to connect into the VPC. So here in the project, you'll configure the VPC you want it to connect to, the subnets you want it to use, and then the security group you want it to use. And then, down at the bottom, you can start to see I've got the Redis host set as an environment variable. The build succeeded once I added the VPC. And here you can see, again, the Redis host environment variable that's actually connecting into the Elasticache cluster in my VPC. And then now I can see that the service did actually connect to the Redis cache, and now it's actually setting values into my cache. So now I can make sure, before this ever gets to the test stack, I can make sure in pull request, in code review, that all of the integration tests are going to pass once it gets into my release process. Let's talk about parallel builds. Can someone review my pull request, please?
Come back in an hour when the PR build finishes.
Too slow. So this is a speed boost, right? If it takes an hour to build, then I'm not being super productive. I'm just waiting around all day for my pull request builds to finish, and then finally my team will review my changes. So here I'm going to show you how it works in GitHub. When you propose a GitHub pull request, it's going to kick off multiple builds. Let's see what that looks like. So I have my add subtraction test pull request here that we looked at earlier. And normally I would only kick off one pull request. We saw one pull request build. We saw this earlier. Why not 2 or 3 or 4 or 5? So what I'm doing here is I'm actually kicking off different types of tests. So one of the things that I said earlier is that you can have multiple build specs in your repository that you use for different tasks that you want CodeBuild to run. So here I'm doing some static code analysis against a SonarQube instance that's in my VPC. I'm doing my normal unit tests, and then I'm also doing my integration tests. So all three, I can see which ones were successful, which ones were failed. So here, my unit tests may have passed, but both my code analysis and my integration tests failed. So this is something that would have, 1, lowered the quality of the code base, which we don't want to do, and then 2, would have blocked the team once it got to this test stack. I can also, as I said, split up the unit tests. So here, this is an example of 2 different build specs where I'm splitting up my unit test suite. So basically, I'm running everything labeled as calculator tests in the first build, and then everything else, all the rest of my unit tests in the second build. So that would split everything in half, hopefully. What you would end up seeing on the GitHub side is that you would have 2 different CodeBuild projects, and then 2 different webhooks that were targeting CodeBuild. And then you'll end up seeing the 2 different checks in your pull request. Isn't continuous integration great?
Man, it's so great.
You know, I don't often say this, but I feel so productive now.
Yay! OK, so summary of pull request checks. We ran a build while code is still in review. The feedback loop is still the time that it takes to build the code. So we looked at different ways to speed up that process. But the team impact is awesome. So broken code doesn't block the team, hopefully. We prevented it from unit tests from failing for other people, integration tests failing for other people, the release process from getting blocked. And then we looked at a couple of speed boosts to keep us going faster around that wheel. So we looked at integration tests, and we looked at parallel builds. So final thoughts, and then we'll have some time for questions. So we looked at these 3 different techniques: nightly checks, branch level checks, pull request checks. And we saw that they each have a different velocity, and they each have different speed boosts. One of the things that I want to really emphasize is that your continuous integration process is likely a combination of all 3 of these. Right? So we looked at really great uses for nightly checks, automating the code base. We looked at branch level checks. Even if you're using pull request checks, branch level checks can be a final check before it gets into the release process. And then finally, pull request checks, where we're really removing a lot of the blockers for the rest of the team for person who pushed a bad change. So if I want to sort of categorize the speed boost categories that we looked at, one is automate the boring stuff, right? That makes for happier developers. But it also makes for safer, more secure code bases, and overall more code base maintenance that's being done. The second was surfacing failures. So your team is going to be blocked, and they're going to be less productive and have less time for new features and new code if they know about failures. So we looked at email, Slack, build badges. This is a place where you can get creative with Lambda functions. So you can write glue for yourself for whatever makes sense for your team, however you want to be notified about failures. Number 3 is to check faster, right? So if I don't know that my build is broken for hours and hours, then it's going to be a while before I get back to fixing that change. So we looked at caching and we looked at parallel builds. And then finally, check more stuff. Check much deeper into your code base. So we looked at integration tests, but this is another place where you can get really creative, whatever works for you. So for my team, we wanted to do static analysis with SonarQube, as well as integration tests against a Redis cache. But this is really where it needs to make sense for your application specifically. So for my change, it was I needed to test against the caching infrastructure. But there may be other infrastructure that you want to test against, do integration tests against, or bring in different tools. So specifically, I use SonarQube. You may use Coverity or some other tool that you have. Adding all of those into the pull request will help you to catch all of those things earlier and faster. So again, coming back to the continuous integration wheel, all of these techniques help us to go faster and faster around this wheel and to get happier and happier developers. So anywhere that you start is, just pick a starting place, figure out what your velocity is around the wheel, how often your team is getting blocked, how often bad changes are getting into the release process and blocking other changes from getting to production, and then start to make tweaks to that, right? So this is a very personalized process, a personalized workflow for your specific team and your specific application. So start somewhere and then start to iterate across this wheel. So we have about 10 minutes for questions. I want to give a quick shout out to a Chalk Talk that's going on tomorrow, DEV322, where we're going to talk more about continuous integration and specifically focusing on pull requests and pull request workflows.